Hi there. In this video, we're going to solve two more problems. And instead of writing out all the 5 steps, I'm going to concentrate on step 4 because we're going to do a unit conversion and we're going to do a problem with geometry. So I'm going to focus more on the nuts and bolts for these two problems. So again, just pay attention to whatever directions you have on whether you need to write out the whole process or whether it's more abbreviated problem. Okay? So for the first one, solving problems with unit conversions. So whenever we have some different units, let's look at that. So a medicine package gives a dosage of 0.65 milligrams per kilograms per day. So we've got quite a rate here of a medication given in 2 doses. Okay, so we've got 6.65, 2 doses. If the child weighs 40 pounds, how many milligrams do they need? Okay, so there's one question. If the chewable tablets come in either 3 or 5 milligrams, which ones should be purchased and how many tablets should be given? Okay, so we've got some units here, right? We've got pounds. Child weighs 40 pounds, but the medicine is in milligrams per kilogram per day. So this is where the unit conversion comes in, right? We need to know how many milligrams of the medicine. Medicines are often in metric, but our weight is in pounds. So we need to find a conversion factor, right? So I'm going to start by just looking up any conversion factors we need. If we need more, we can look them up later. But we need pounds to kilograms, right? And in our textbook, I want to show you a page in our textbook here, or you might have a handout. Here in the problem-solving chapter, after the problem-solving process, we have some different some different charts here, tables with different conversion factors. So we've got length, weight and mass, volume and capacity, and then there's some examples as well. We need kilograms to pounds. So 1 kilogram is approximately 2.2 pounds on Earth. So this depends on the planet's mass. So you know how astronauts on the moon don't weigh very much, they jump around, they weigh a lot less. That's because less gravity on the moon. So this only works on Earth, but I think we're pretty safe in doing this calculation since we are on Earth. So I'm going to write down 1 kilogram is approximately 2.2 pounds. Okay, I'm going to abbreviate there. Okay, so I think we can go ahead and figure out how much this child weighs, right? So if we take the child's weight in pounds, change that to kilograms, then we can figure out how much medicine to give this child, right? Okay, so if the kid is 40 pounds, I'm going to do this 2 different ways. One just kind of intuitively, and then I'll set up the other one with dimensional analysis so you could see which one you like better. First, I'm going to just do use my intuition, like should I multiply or divide here? So 1 kilogram is 2.2 pounds. Okay, so I've got pounds and the kilograms are less than that. So that tells me the kilograms are going to be less than 40, so I need to divide by 2.2. That is how I do it intuitively. You might do it that way or a different way. 40 divided by 2.2 is 18.18. Okay, so that would be 18.18 kilograms. Okay, now before we do the medicine, I'll show you this another way that you might like as well, and it's called dimensional analysis. I'll use a different color. You might have seen this before as well. If I start with the number I need, I start with the number I have, and I'm going to write the units. It's very important to write the units because we're going to line up all the conversions so the units cancel out. So if I have 40 pounds, then I can make it into a fraction by just putting over 1. I'm going to list however many conversion factors I need to get to the units I want. Now this one only has 1, which is nice, but we have kilograms and pounds. And if we put the same value on both top and bottom of the fraction, it will equal 1. So that's why we can multiply by this number. And it won't change the value, it'll just change it into the different units. So because I have pounds on the top, I want pounds on the bottom, so it'll cancel out. So I'm going to put my 2.2 pounds down below, and that is equal to 1 kilogram. Okay, so then because the units of pounds cancel out, we're going to end up with kilograms at the end, and that's what we want. And notice how, because you multiply fractions straight across, this is in the bottom, so we're going to divide. So it does end up to be 40 over 2.2 kilograms. And we have that. I could type it in again, but I've still got it right there. 40 divided by 2.2 is 18.18. Okay, so whichever way you do it, just show your steps, show your work. If you prefer, if you have a sense of it, you prefer to do it more intuitively, you can do it that way. If you want to write out the units, you can do it that way. And this is very helpful when there's more than one rate. Sometimes you could have a few of these in a row, or maybe you're converting a rate, so it's the top and the bottom. It can be really helpful to write that out. So I definitely recommend it. Okay, so we've got the same answer up to this point with two different ways. So that's another way another good benefit of this is doing it two ways. We know the child weighs 18.18 kilograms, and we need to give 0.65 milligrams per kilogram. Okay, so in fact, we could use the units again because this is a rate. So intuition tells me we're going to multiply this, but I'm going to write out the units. So we have 18.18 kilograms, and then this is milligrams per kilogram. So if I did write this out as 0.65 milligrams per each 1 kilogram, right? So I'm kind of using this same method over here. Those cancel, and yes, in fact, it is multiplication. 18.18 times 0.65 is 11. I'm going to just cut it off, 11.8 milligrams. And now it's still per day, right? So I could have said kilogram per day. Still 18 milligrams per day. Okay. We're not quite done yet, right? Because we also are giving it in 2 doses. So we would need to cut that in half, assuming 2 equal doses. So 11.8 divided by 2. And I've already got it in my calculator, so I'm just going to divide that by 2, and I get 5.9. Sorry, I'm looking at my notes and I did something different. But I think that way was wrong and this is right. Okay, so 11.8 divided by 2, and that's 5.9 milligrams per dose. Okay. So now we've got one more. That's the first question. How many milligrams do they need? Is this per day or that per dose? If the chewable tablets come in either 3 or 5 milligrams, which ones should be purchased and how many tablets should be given? Okay, well, this is really close to 6. Okay, so you could say 2 3 milligram tablets. You might want to check with a doctor, of course, before you do any of this. And I'm going to say it looks like 2 3 milligram tablets twice a day is close. But this is not a substitute for medical advice. Check with your doctor. Okay. All right, so I think we answered all of the questions. How many milligrams do they need? 11.8 milligrams per day, 5.9 milligrams per dose. And then if we did 2 of the 3s, that equals 6 tablets twice a day. Okay, great. So now let's do the second problem on the page here. This one has geometry in it, and it also might have some units as well, because often with geometry you have units. In this case, we're pouring a concrete patio with the shape of 2 overlapping squares. Okay, so we've got a diagram here. Move this up a little bit. We've got a diagram. We want the concrete to be 6 inches thick. We've got 2 overlapping squares. If each square is 12 by 12 feet and the overlap is about 3 by 4 feet, how many cubic yards of concrete should you order? Okay, so if you've ever done any home improvement projects, you know you have to do some math, right? Area of your deck or whatever you're working on. Okay, so we have a diagram. This deck, or sorry, this patio is kind of shaped like two overlapping, it gives a nice shape there, 2 overlapping squares. So it looks like this is a 12 and this is 12 by 12, but then here there's this overlapping part which is 3 by 4. Okay, it's hard to see that. 3 by 4. Okay, so it looks like we need to calculate the area of this this whole patio, and then we need to make it 6 inches thick, right? So I want to show you back in the book, there are also, after the unit conversions, we have examples of geometry. We have some formulas here. So we have rectangles or squares, circles, cubes, and cylinders, or boxes, because it doesn't have to be a perfect cube. So we've got formulas here that you can use. So we're trying to find area, which is the inside amount, right? Perimeter would be a fence. That would be the outside. We have area as length times width, and that gives us square units, like square footage. You would buy carpet in square feet. So we're going to use area as length times width. So I'm going to write my formula that I'm using here. Okay, so that's for each square, but we're going to add some together, right? So we have a 12 by 12 square, so I'm going to add that 12 by 12, and then we have another 12 by 12. But we don't want this 3 by 4 section twice, right? It's just, this is all one level. But we're just kind of estimating the shape, the area using these 2 shapes, but we need to take away this part because we don't want to order that twice. We don't want that extra. So we're going to subtract the 3 by 4 rectangle. Okay, so let's see what we get here. So we have 12 times 12. 144 plus another 144, and then that's minus 12, right? A lot of 12s in this question. So 144 plus 144 plus 12 gives us 300 square feet, right? Or feet squared. You can write it either way. 300 square feet. Oops, sorry, I just caught my error. 144 plus 144 minus 12. I thought that didn't sound quite right. Okay, 276. If you caught that, great job. 276 square feet. Okay, so we can't order the concrete yet though, right? Because that's the area. We need to make it 6 inches thick, because we're going to put heavy furniture and barbecue and fire pit, all that kind of stuff on it. So we actually need to find the volume. And this cubic gives us an indication that that's volume, right? Because that's cubic. Volume is in cubic units. Okay, so the volume, we're going to take our 276 feet squared times, we need to get cubic, right? So we need another foot, but the 6 is in inches, okay? So we need to get that into a foot. So a couple ways to do this. You could say, well, 6 inches I know is half a 12, so that's half a foot. You could do times a half or times 0.5. If you weren't sure, or if it wasn't quite a nice number, you could do 6 out of 12. If it was 3 inches, you could do 3 out of 12. And that is going to turn it into feet as well. So now if I take my 276, either times a half, times 0.5, or times 6 out of 12, however way you want to do that, that's 138 cubic feet. Okay. All right, so we've used our geometry formulas for area as length times width. I didn't show you the volume one, but the volume is length times width times height. So that's what we did, was we took our area essentially times the height. Okay. Now where are we in this question here? So how many cubic yards of concrete should you order? Okay, so when you order concrete, it doesn't come in cubic feet, it comes in yards. And when they say yards, they mean cubic yards. So we need to convert this. So we actually, in addition to geometry, we have a unit conversion as well. And we already used the 1 foot equals 12 inches. I'll write that down here. Those are in the table. 1 yard, do you know how many feet that is? That is 3 feet. Okay. But what's interesting is we're not just converting feet, we're converting cubic feet. So let me show you a way, in case you're not familiar. You may have done this before, but if not, let me show you how we can do that. So I'm going to use the dimensional analysis like we used above. I'm going to start with my 138 feet cubed over 1. And just like before, I'm going to write my conversion factor here, which we need to go from feet to yards. So I need feet on the bottom, which is 3 feet to 1 yard. I'm going to yards, so I want yards on the top. Okay, but feet cubed isn't going to cancel out with feet. So I actually need to cube this entire thing, which means third power. Okay, so I'm going to simplify that down below into 138 feet cubed over 1. I'm going to cube each of these. So this is going to be 1 cubed is still 1, because 1 times 1 times 1 is still 1, but it's cubic yards. And then I need to cube 3. 3 times 3 times 3 is 27. Right? 3 times 3, let's just double check it. 3 times 3 is 9. Yeah, 27. Okay, so that means I'm going to be doing 138 divided by 27. Is 5.11 cubic yards. Okay, and I just want to show you how my units canceled out. So the cubic feet and cubic feet canceled out, which left us with cubic yards. Okay. Okay, now it depends on what you can order, right? I don't know, I doubt you can order 5.11 yards, plus you might want to add a little extra. Often in construction they add 10%. This might be an estimation anyway, so you might want to bump it up to 6, or maybe you can do a half a yard. I don't know exactly how that works. So you would want to call the concrete company and see how they do their orders. But I would order over 5 yards, right? I would order, say, 5.5 probably at a minimum to 6 yards, and I'll make it cubic yards because that's what they mean, is cubic yards. That's just an abbreviation. I would order 5.5 to 6 yards of concrete. Cubic yards of concrete. Okay, great. I hope those 2 examples helped, and I will see you in the next video.